Okay, so we did the duplication of the line segment last time and the perpendicular bisector. The two other things we need to go over is how to duplicate an angle, and there's something else. Let me look at something else. I don't think off the top of my head. Oh, and how to bisect an angle. That's what it was. Duplicate an angle and bisect an angle. So the way we duplicate an angle, let's start off by drawing an angle. So everybody draw some sort of acute angle on your paper. We can do it with an obtuse, but just so that we're all kind of have the same idea. So you're going to draw some sort of line segment. And then another line segment that meet at a vertex. Sorry. Top. There you go. I didn't have words. And let's label this angle A, B, C. So this is duplicating an angle. So drawing the exact same angle. Okay, so we are going to, let's go ahead. No, never mind. I don't want to pass out protractors. I was gonna say, let's measure it, make sure that we end up with the same thing, but I don't want to have a protractor. We don't have time for it. So the way we duplicate an angle, anybody have any ideas? This is the one that I can never remember on my own. I have to like think about it every single time. Anybody have any ideas on how to duplicate that angle?
I would just do this thing and set it on the vertex of B and then find a dot to find A at least.
Mm.
So
Okay.
you could duplicate B and A by using that.
Okay. To find that, yeah, that would get you that.
At least that point.
Yeah, that we're really looking for this opening right here, right? So if I'm going to duplicate the angle, the idea is let's draw the bottom part somewhere else. Okay, so I have the bottom part done already. Agreed? Mm-hmm. Like this is gonna be my new angle. This is the bottom of my new angle. I need to figure out where to put up here. The way when we're duplicating, you usually put like a little apostrophe. Nope, on the new one. Sorry. This is my original ABC. This is my new version. And my new version.
How did you get the bottom part again?
I just drew it. It's just a line.
Oh, okay.
Yeah, you just start off drawing a line, but the idea is I don't know how much this opens now. So I need a dot somewhere so that it will be the exact opening here.
Yeah, okay, so you can start
You have
by
a ruler?
We do not have a ruler, but I can technically, the idea is like duplicate a line segment. I can measure.
Right. Yeah. So just like from the opening to the line, not, you know what I mean? Like from point A down to the line below it. Can you just mark off how much that is and then try to duplicate that?
And so she's saying, can't I measure like from point A right here to say this point down here?
Yeah.
With
Like
that is, where is that at here? Like, is it over here? Is it over here? Is it up here? Is it over here? Is like, there's too
if
many.
you measured from B to that point on C.
So the idea is, so what she's saying, I can measure this way and I can measure this way. The problem with that is measuring this way, it's all in that line, but measuring this way, technically it could be here, it could be here, it could be here, it could be here, it could be here. Like I have lots of different, it needs to be the perfect exact angle of what you did here. And I can't make a perfect exact angle because that's what I'm trying to do is make a perfect exact angle. So kind of the idea of what we're going to do is you can do it with the dots we already have here, the A and the C. The problem is it's going to be really, really big. Remember how we did it last time? Let me see if I can find it easily. Yeah. Instead of making, it was the page after that. This one, remember how instead of making a huge circle with that, we picked 2 dots and made smaller circles? We're gonna do the same idea here. So what we're gonna do is we are going to center our compass at B. So you're gonna center your compass at B, and we are going to pick a dot somewhere on here. It does not matter where. The further out you do your dot, the bigger your circle is. So I'm gonna pick just this dot right here. And I'm going to draw the arc. So it doesn't matter which point you pick. We should all have our original angle and some arc here. Agreed? So, you can do that. We can go ahead and put that arc over here on our noose, like our ray we already have. So use that exact same dot. So let me remember which dot I used. I used the second one right there. I'm going to center it on my new vertex. And I'm going to draw my arc again. So all I've done is just draw an arc on both of those. Okay, so right now, question.
No, I
Just pick a dot and draw it.
well, I thought, would you just go over to the new point that you made on that line? And then make another arc,
Mhm.
and wherever it intersects is where.
So the idea is right now, this dot right here, like if I label these, let's call this A, B, C, let's call this D, and let's call this dot E. I have the dot D down here, right? Everybody agree I have my new version of D down here? I don't have E. And the problem is I can't just guess where it's at. I can't say E's here or E's here or say, it looks about right here, because then I'm just guessing that angle. So a way I can figure out the exact distance is figure out the line segment from D to E and draw that same line segment over here. Does that make sense? So now I'm going to center at D, find the distance to E, which for mine is this point right here. And I'm going to do the same thing over here. So put my center at D. I know my dot's going to be right here. And that right there is where my new line or my new dot E is. And so now, since I have 2 points, I can draw a line. And let me just show you, let's see how close mine is. Again, there's some human error in the drawing here, but for the most part, it should be pretty close. My original angle was, looks like it was 51 degrees. And my new angle is a little more this time. And it looks like it's like 53 degrees. But pretty close. So if you need steps here, so you can remember how to do this, I'm one of those people that has to have steps written down for this one. You draw the bottom ray as your first step. And then after you draw the bottom ray on the current angle, so I'm gonna call it the old one, on old angle, you want to use the vertex. In this case, it was B. So I'm gonna put B in parentheses as the center. And draw an arc that intersects each side. Each ray, how about that? That would be a better way to say it. And then you draw, we're gonna do the same thing on your new ray. So on the old angle, we do that. On new angle, draw the same arc. So that gets you the arc here. The way we figure out that exact point is we go back to the old angle and we center it at our new points. Let me go ahead and label, draw an arc that intersects each ray, and it intersects at D and E. And then now that we have those points of intersection, I center at D. So I put the center at D and find the spot on the compass that makes the other point. So I'm gonna find the radius of DE and draw on new angle. And where they intersect will be the point.
And you should the same thing, it's obtuse, obtuse, obtuse.
Yes,
They're just gonna.
yes, it's just gonna be bigger circles. Okay, questions about that? Good with that? Okay, the next thing we need to do is to bisect an angle. So the way that we bisect an angle is we need to start off by drawing an angle. So we're going to draw some angle. I'm going to do an acute angle again. Any ideas on how to bisect an angle? So let's call this F, G, and H.
You start with the same step as duplicating?
So first of all, what is an angle bisector?
It cuts through the center.
It cuts through it, so I am not gonna have to draw a new angle. I would just be using
Yeah.
this.
But do you need to make?
Halfway point between F and H.
Do we know how to figure out the halfway point between F and H?
Could
Maybe make
the
a-
protractor like the center of it on G and then something along the lines of picking a line in the center. F and H.
But would that be the exact line?
Probably not.
It'd be a good guess, right? So. We are gonna start off,
Just take your marker F. And then pick a point, and rotate it down, and then put your mark on H, and then. And then whatever the intersection of that is.
he said, couldn't I put my center on F and pick a point somewhere and draw a circle? And then put my mark on A, or my center on H, and use the same point and draw a circle? And shouldn't they intersect in the middle?
Yes, but they're not on the same exact point on the line, does that matter?
So. Perfect. That is together, you win the prize. Yes. So you were totally exactly on the right spot of put your dot on F or center on F, find something here, a circle, same thing with H, the intersection is gonna be the middle. The problem with our F and H is this H is further out or not as far out as this F, because I randomly just threw them on there. So you need to have 2 points that are the exact same distance from G. So how am I gonna get 2 points that are exact same distance from G?
Okay, I'm just guessing here, what if you do it, if you start at G and you make a little circle somewhere, and
Bingo.
you make points.
Yes,
and
so
then
I
do
start off
that,
the same way, yeah. Do an
but
arc
then you do it.
to, yes. So we're gonna start with yours and end with yours. Okay, so we are going to draw an arc like we did before, so that my 2 points are the exact same distance away from B. Or for, in this case, G. So I'm going to start off and put my protractor, not my protractor, my compass. I'm going to center it at G, and I'm gonna pick some dot somewhere and make an arc. And that gives me 2 perfect starting points. Let's call that J and K. So step 1 here is to draw an arc centered at G to create 2 points, which would be J and K. And now I'm going to center at one of those points. I'm going to do K first. Pick a dot somewhere. And draw your circle. Yes, a circle. And which one did I do? This one. Last one, okay. And then go from J, do the same thing with the same spot. This one. And those intersections should be the exact middle. How many points do I need to draw a line? 2 points. Do I have 2 points? Yes, my vertex and the new points I just drew. And if I measured, I'll write and then I'll show it's the angle bisector. So I drew an arc to two new points, and then I center at K, draw an arc, center at J, draw the same arc. It has to be the same arc. And then intersection point, connect the intersection point in the vertex. And that's your angle bisector. And for mine, my initial angle was, my initial angle looked to be about 42 degrees, and that is 21. I mean, that is like on the dot. I feel like there's less room for error on this because you're not picking up and moving it to another part of your paper. You're just working with the same angle. So that's how you bisect an angle. Questions about that at all?
Probably be off if you had to duplicate the angle and then duplicate bisector. You had to make another angle that looked like that angle
Mhm.
and then bisect that angle.
All the things. So that was, I think that's all the stuff you show on your homework. Look at your homework, the construction thing. Just trying to show you where it's at. Oh, here's. So on your homework, you're duplicating a line segment, duplicate an angle, perpendicular bisector.
And this homework's also due tonight, right? No, Tuesday.
No,
Tuesday. I mean.
Tuesday,
Yeah,
yes.
right.
The one tonight is the bookwork.
Yeah.
Yeah. This one is draw an acute angle, bisect it. This one is construct each angle, get with that measure and label it. Don't use a protractor. So how in the world are you gonna make a 90-degree angle without a protractor? Huh?
A ruler?
No, because it will be perfectly 90 degrees. So how can you make a 90-degree?
You do the perpendicular bisector.
A perpendicular bisector. If I just drew some line here and I bisected the line, that would give me a 90-degree angle, right? So once I have a 90-degree angle, how can I get a 45-degree angle?
Bisect the angle.
Yeah, duplicate this angle and bisect it.
And then both of those together.
Duplicate this angle, put it here, duplicate this angle, put it on the other side of it, and we'll make it open 135, right? Because if you duplicate your 90-degree angle and then your 45-degree angle, start here and do 45 degrees. Won't that make it 135 degrees? So that would be kind of the idea for that. Questions about that? Okay, so that is all of constructions. That's what we needed to complete last time. Check, we're done with last ones. So now let us move on to today. Today we are talking about triangles, all the triangles. And we're going to spend a good chunk of time on triangles now. So far with triangles, we've talked about how to how we can classify them by their sides, by their angles. We talked about how the angles added up to be 180 degrees, right? So the three angles inside of a triangle adds to be 180 degrees. That's called the triangle sum conjecture. What about sides? Do we know anything about the sides of a triangle? Do they have to add to be something, or is there any equation or anything we can do with sides?
Plus b squared equals c squared.
Okay, so this is triangles still. So yeah, we know the sides of certain types of triangles have to be a squared plus b squared equals c squared. What is that? What kind of triangles is that for?
Is it
You're about to say it.
right?
A right triangle. Yep, sides of a right triangle. So that only works for right triangles. Most triangles are not right triangles, right? So do we know anything else about the sides of other triangles?
No.
No. So, let me pass out some patty paper and let's do a few. Well, actually, we don't even need patty paper for it. You can do on paper. So what if I said draw a triangle with sides that are length 3 inches, so we're going to draw a triangle. And we're not constructing here. We're actually using a ruler and drawing. So if you need a ruler, I'll get you one. So we're going to draw a triangle with side lengths of 3 inches or centimeters. I'd probably do inches, 4 inches and 5 inches. 4 centimeters, doesn't matter. Depends on how, just put a unit here, it doesn't matter. 3, 4, 5. So if you want a ruler, I have a ruler. Or your protractor, nope, your compass has some measurements on there, you might be able to get away with. Or the, you want
I'm
this?
trying to do.
Do it. You want one?
No, man.
So if you do centimeters, it makes it a little bit smaller. So. I'm gonna do 5 on the bottom. Okay, so I have 5 on the bottom. This is my 5 centimeters. If I wanted to do 3 and 4, I can't just randomly draw 3 and 4. I'm gonna do it so that you can get both sides on there. Any ideas?
Are we using a compass to do it?
No, this is truly just common sense, like there's no construction or anything. I did not mean that dumb, because I just said I don't have common sense. Couldn't you use like another ruler or say this one's 3 centimeters, so it has to be to this point, and this one's 4, and where do they match up? Oh my goodness, I made it perfect the first time. But if you didn't, it's like if I made this 3, well, that's too long, so I need to move down, right? Couldn't you kind of use 2?
That's what I did. All I know is you can't make it a right triangle using this.
Okay, you can.
No,
It's Pythagorean triple, that's why I picked those numbers. 3 squared plus 4 squared equals 5 squared.
Well, let the other.
where's the, oh, well, I guess. This is how I started. I don't think you can get it to work.
Oh, wait.
I put 5 on the bottom.
So look, here's mine, here's
and I
my
was gonna
3.
put 3 on here.
Remember, this is gonna be 4 centimeters.
Basically, for 5, you can do right triangle with 5 is your,
5 has to be the hypotenuse.
yeah.
Oh, look, there you go. There's your right triangle. The reason why I said this is I knew they worked like triangle, because they're.
That right triangle works, what I was trying to do when it.
Oh. Yes, the
The
biggest
4
number
won't
has to be
get
the
there.
hypotenuse, you're right. For sure. Okay, this time. Give you a second to finish that up. This time I want you to draw a triangle. With these lengths. 2 centimeters, 5 centimeters, and 8 centimeters.
You know what do I do if I don't have a, second ruler?
I can just get you a ruler right here.
Sorry, I should write that. Oh, I'm sorry.
Here you go.
Yeah, I should have told you, Didn't realize I would need 2.
So if I start off with the 8. So there. And then if this is my 5, let me do it. Here's my 5, starting there, it goes up to here or whatever. Here's my 2. I need to get them closer. There's 5, here's 2. Even if I like made it as small of an acute angle as possible, is it gonna meet? Oops, sorry. Like here's my 5. Let's say this is, I can probably get a little more acute than that, but this is the tiniest little angle, right? This is 5. This one's 8. This one's 5. And this one is supposed to be 2. I can't get it to touch. Why can I not get it to touch? Look at that picture. Even if I move the 5 down closer and the 2 down closer, why can I not ever get it to touch?
Oh, because, they always have. They've gotta be bigger together than the biggest one.
And you can look at this picture, if I had this 2 almost as close to here as I could, and this 5 as close to here as I could, that would be 2 plus 5. Is that ever gonna equal 8? No, it's never gonna equal 8, right? So what do you have to say about these two numbers?
They have to be greater than 8.
Yes,
Or the hypotenuse. Is the hypotenuse always the biggest number or no?
hypotenuse is the only on the right triangle, so this is not a right triangle, so this is just, we're calling them legs, your biggest leg. So your biggest leg, the other 2 legs have to add to be greater than that or greater than or equal to. Can it be equal to?
That's what it is.
If it was equal to, what would it look like?
Or-
It'd just be a line on top of a line, right? So that's called the, say again? Okay, so this is called the triangle inequality. And you probably learned this at some point in your life, but it probably didn't mean anything to you at the time, if you didn't remember it now. That the sum of 2 legs has to be greater than the other leg. And every combination of this, so A plus B has to be greater than C. B plus C has to be greater than A, and A plus C has to be greater than B.
What did you call it?
The triangle inequality. And the reason why it has to be all a combination of them is if you just check one of them, if I just said, well, A plus 5 is greater than 2, check, right? You have to check all of them to make sure they all work. So this one doesn't work because 8 plus 5 is greater than 2, check. 8 plus 2 is greater than 5, check. But is 2 plus 5 greater than 8? No, that's where it fails. So it has, every single one of these has to be true to create a triangle. If it does not, this is not true, you cannot make a triangle with it. And we kind of showed why, because when we put them together, it won't even fit on top of the line, it's too small. Okay. So that is something that might be useful at some point. You kind of have a lot of homework out right now. So there is another homework assignment that I put on D2L, but I made it due a week and a half from now. So it's not due next Thursday. There's more time on it. So this is one of the papers on it, is with the triangle inequality. And here I can pull it up and show you. So, let me pull it up real fast. So on week 2, you have this paper I passed out last time that is due next Tuesday. This 4143, I made it due the Tuesday after that. It is a longer assignment. It's actually 3 papers, but they're not terrible. This one is, also, as you're working these out, if you're struggling with something, like look at the title. This is called the triangle sum conjecture. So you're going to use the information that the 3 angles in a triangle add up to be 180 on this. Okay, so if you get stuck, try to find 3 angles to add to get 180. And there are a few that are a little bit difficult on this, and I'm happy to help you with this as you work through it. Part 2, 4.2 is isosceles triangles. 2 legs are the same, 2 legs are congruent. The base angles are congruent. You're probably going to be using that on most of these. And this last one is triangle inequality. So it gives you 3 legs. Can you make a triangle out of that? Those sorts of things. Okay. So that is not due for a week and a half. So if you have just extra time, or you like to get all your homework done on the weekends or something like that, it's available, but you have another weekend before then. Okay, so we are going to move into triangle congruencies, and we are going to spend a chunk of time on triangle congruencies because it is a really, really important topic. So what does congruencies mean? What does congruent mean? Let me sound out congruencies. Congruencies, there we go. Just imply I don't write in pencil when I take notes, so I write too. Bring me a pen, just a minute. Triangle congruencies. So how can you tell if two triangles are congruent? Does anybody remember how to do this? How to tell if triangles are congruent?
The measurement, their size.
Yep, so you can look at some sides, measurement of sides, measurement of angles, and certain combinations work and certain combinations don't work. Okay, so one combination is, what if I have two triangles and all three angles are congruent? Okay, so what if I have two triangles? Two triangles with three congruent angles. Would those triangles be congruent? So we are going to, there are 1, 2, 3, 4, 5 of this in class face-to-face today. So what we're going to do is we are all going to draw a triangle that has three congruent angles on this patty paper, and then I'm gonna see if they all line up and match. So we are going to draw a bottom leg on your paper. So use a straight edge. You do need your protractor for this part. So we're gonna measure it out. So draw a straight edge for some line on the bottom. What angle do you want to be on the bottom left corner? How big?
60 degrees.
60. Let's do something other than equal out a triangle. Something greater than or less than 60.
45.
45. Good choice. 45 sounds great. So we are going to draw a 45-degree angle. So using your protractor, measure 45 degrees. You're going to put a dot there at 45 degrees. I'm going to put my dot there. And then you would draw your line. I don't really know where it's going to intersect at. What angle do you want this bottom right-hand corner to be?
52.
52 degrees. How about 55? Because it is a little easier to be exact. So 55, so you have to do this the other way on the protractor. So line it up, measure out 55 degrees this time, and draw it out so that it connects. So here is my triangle. You may have a little part where you drew too far, but that's okay. If you need to connect more dots, extend lines to connect dots. Okay, so now we should have a third angle that is congruent. Agreed? Why? Because if this is 45 degrees and this is 55 degrees, what's left over for the last one?
80 degrees.
80 degrees. I'm gonna go ahead and measure it just to kind of prove that. Here it is, and it is exactly 80 degrees. Okay, so we should all have, there should be 5 triangles, kind of paper, that have the exact same measurements. Agreed? Everybody agree? They should look exactly the same, right?
Right.
I think yours. I mean, and even if they're off just a tiny bit, they should match up pretty well, right? So here's our first one. Here's our second one.
That's not mine.
Here's our third one. All of our angles are matching up though, right?
The angles match up
Here's our third one.
All different ones.
And this, I'll save the best for last. Not even, none of them match up at all. We have 5 completely different triangles. Why? Did we draw them wrong?
No.
No.
No, even if we lined up on this side, this angle matches too. Why are they all different?
You keep it linked sideways.
Because we use different side lengths. What's yours? I know you might keep it
I
forever.
don't remember. I think I'm gonna go with one you said the best one, but I don't think that was there. No, that definitely wasn't mine. No, the one that this one.
Just linger.
I've been kind of framing these patty papers, honestly.
I love it. I put it on your refrigerator. I'm telling you. Okay, so if we have 3 angles, no, if we have 2 triangles and all 3 corresponding angles in the triangles are congruent, do we have congruent triangles?
Not necessarily.
No. Could you? Yes. But is it a guarantee? No, it is not a guarantee. What word could we actually use for those triangles we just drew? They were not the same size, agreed?
Right.
Were they the same shape? Yeah, they were the exact same shape because they had all the same angles. They were the same shape, but a different size. Remember, congruent means same size, same shape. These are same shape, different size. What's the word for same shape, different size? Do you remember? That means they're called similar triangles. So if you have angle, angle, angle congruency, this angle is congruent to this corresponding angle. Angle 2 is congruent to corresponding angle 2. Angle 3 is congruent to corresponding angle 3. Does that mean you have congruent triangles? No.
No.
Angle, angle, angle is not a triangle congruency.
I remember this stuff. There's
Mhm.
like
Yep, this is the AAA. AAA. Not a triangle congruency. They are similar. You can do things with them. You can use that to measure like the height of buildings, right? If you have a tree and there's a shadow and you know the height of the tree, you can measure the height of the building based on the shadow, blah, blah, blah. Because that's like similar triangles, but they're not congruent triangles. So angle, angle, angle is not a triangle congruency. Do you remember ones that are triangle congruencies?
Side angle. ASA? No?
ASA, yes, ASA. So the next one is ASA. Angle, side, angle. And this specifically talks about the side in between 2 angles. Okay, so this talks about, if I had some triangle here, if this is this angle right here, I'm referring to this angle right here, and this one is referring to this angle right here, guess which side it's going to be? The one on the bottom, the included side is what that's called. So the side that is touching both of the other angles. Okay, so this is angle, side, angle. So the idea is it matters the order you write it in. ASA means if I touch it and I'm going around clockwise or counterclockwise, angle, side, angle, or the other way, angle, side, angle. Does that make sense? Okay, so we say this one is a triangle congruency. Let's just talk it out. Why would this be a triangle congruency?
Because if you have one side, we all do the same side, and you have the angles are all gonna meet in the same spot. So those other links are gonna be the same.
It's the exact same idea of what we just did. It's just, I would say, instead of draw a line on the bottom and then the 45 and 55 degree angle, it's draw a 4 centimeter line on bottom. And then all of our triangles are all gonna match up. Does that make sense? So the idea is I could do this exact same problem again with all of us. If we had a little bit more time, I probably would do that. And I would say, okay, now let's get some paper and let's all draw a 4 centimeter. Let's do it with a pencil. Let's do 4 centimeters on the bottom. And now all of our triangles should be exactly the same. Agreed?
If you're using the same angles.
Yes, if we use a 4 centimeter, 45 and 55. Okay, also, this is angle side angle. Then technically the third angle, isn't it congruent also? Does this like, does the extra angle gonna be congruent also? Every time?
Yes.
Why do you say
Wait,
yes?
oh, wait.
Like if this is a 45-degree angle and this is a 55-degree angle, the third angle that we haven't talked about, is that gonna be congruent also? Yeah, why?
Because it has to add up to be.
It's gotta add to be 180, and these are the two numbers that whatever these add to be, plus something else is always 180, right? So this is a triangle congruency. So with angle side angle, if you can prove this angle is congruent, the included side, and then the other angle is congruent, then you have two congruent triangles. So the idea is, if I had some triangle, we'll call this A, B, C, and some other triangle, not drawn to scale, obviously, called D, E, F. I'm gonna actually draw this a little different. Since I'm already have it not looking good, let's go ahead and just completely change it up. D, E, F. How about that? Okay, so I have these two triangles, and I tell you that this angle right here is, I don't know, 47 degrees. And I tell you this angle right here is it's less than 47. I don't know, not drawn to scale, okay? Let's say it's 58 degrees. And this side length is 4 centimeters. And over here, I said that this is 47 degrees. And I said that this is 58 degrees. So 47, 58, I wrote it upside down. I don't know why I did that. Which side over here has to be 4 centimeters to make it congruent? The part in between the angle. This has to be 4 centimeters if I want them to be congruent, right? Now that they're congruent, let's write what triangles are congruent. So triangle, how do you want to write it? How do you want to name it? Because you can call it ABC, you can call it BCA, you can call it CAB.
ABC, that's fine.
ABC. The way you write congruent is you write the equal sign and you put the little tilde. That's a terrible version of it. The little tilde above it. When you write this triangle over here, you have to write the corresponding parts. Okay, so angle A over here, if I started off with A, I gotta write that version of A over here. Which the version of A over here?
I think it's 80.
Yeah, I know, I wrote upside down. I should have, let me rerun.
I'm just kind of far away, I can't see.
58, 47.
So
That's the other reason why I give you printed off stuff of everything.
you'd start with D.
D is also 47, like A is 47, right? So D. Over here, I wrote angle B, which is the angle I didn't know. Which one's that over here?
D is F.
Oh,
It's
F. I
F.
wrote it on my paper.
Okay.
Yeah.
So
Let me change mine.
F. And then the next one was C, which is the 58-degree angle. The 58-degree angle over here is E. So this part matters.
You just have to match up the angle.
You gotta match up. It has to correspond. Because now that I have this written, I don't even have to have the picture anymore. I can say angle ABC is congruent to angle DFE. Angle BCA is congruent to angle FED. Angle CBA is congruent to angle EFD. line segment AB is congruent to line segment DF. Line segment BC is congruent to line segment FE, so on and so forth. Does that make sense? So now that I've shown these three things are congruent, I can now also say BC is congruent to which one over here?
FE.
FE. BC across from the 47-degree angle is congruent to FEEF across from the 47-degree angle over here. I can also say AB, I'm gonna put 2 marks on that, is congruent to which one? FD. It's across from the 58-degree angle over here. Across from the 58-degree angle over here is FD. Does that make sense?
So the angles don't have to be the exact same, like, they don't all have to be 45.
No. It means this angle has to
Matches
be
with the other.
matches with this one. This one matches. So 2 match. And the side in between the 2 that match. Okay, so we said very specifically the included side. What if the side was a different side? Would it still work that way?
It would work, but it wouldn't be written.
Correct. Why do you think it would be, why would you say it works still?
Because it's still not, like, the angles all still match up and the sides are the same.
Oh, yeah.
So the reason why I can do this is because, so this is a version that you're allowed to use. The other version is angle, side. What if I had 2 angles still, but this time it's any side, not the included side, any of the other 2 sides? The reason why this still works, this is called angle, side. So this means 2 angles and the not included side. So I have 2 other options here. It could be any of the other 2 options. Oops, sorry. Think back to your picture.
Oh, wait, did you ask, what was the question?
I'm asking you again. Think back to this picture, not this picture. Think back to this picture. Why could it be this side over here or this side over here?
Did you know the other angle, the tall?
Because you know the other angle. That's the kicker is I know 2 angles here. Really, I know 3 angles here. We only call it ASA, but the idea is if you know 2 angles, the third angle is 180 degrees minus those 2 angles. Agreed? So technically, I'm gonna erase this, but technically this is like angle, side, angle. So take off this angle, pretend like this is the one we don't know. Side, angle, pretend like this is the, you know what I mean? Like it doesn't matter which one we don't know because we do know it is the idea. So angle, side, angle, and angle, side are the same idea. 2 angles and then another side. It doesn't really matter where the side's at. It could be in between the 2 angles. It could be all around any of the other sides.
But that doesn't apply for AA.
It does not apply for angle because that will never create congruent triangles.
But does it
No.
apply for ASA?
Timeout. I said never create congruent triangles. It can sometimes, but it's not a guarantee they're congruent triangles. Does it apply for this? Yes. If you can show this angle and this angle are congruent and this side is congruent, then the 2 triangles are for sure congruent. Yeah. Okay. So that is 2 that work, that are congruencies. What else works?
Side.
Side. That should make sense that side works. Why does it make sense that side should work?
Sides are the same.
The sides are the same, so the angles have to be the same because you can only open up so big to make that side. And also when you have 3 exact lengths, like if I gave you Q-tips right now, you can only make 1 triangle out of that because they only fit together one way. Okay, so side. We don't know anything about any angles, but just based off of side, I can say I have 2 congruent triangles. Okay, let's practice that. If I had, oh, you know what? If we would have done this on patty paper, this 3, 4, and 5, like we could match up, like all of our pictures should match up right now. Agreed? I mean, we may have to turn them around depending on how you drew it, but 3, 4, and 5, like this should match up perfectly. Maybe next time I'll remember to do patty paper on that, and then we can match them up perfectly. But the idea for that, for side, 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 is if I had 2 triangles, we'll call this one H, I, J. We'll call this one L, M, N. Had a student 2 semesters ago that she would try to make words out of this. And it was real fun when we did quadrilaterals, because she would make certain 4-letter words out of it, and it was just made you smile whenever you're doing geometry coming up. So here, if I said HJ is, I don't know, 7 centimeters. JI is 5 centimeters, and HI is, I don't know, 6 centimeters. Over here, LM is 7 centimeters. MN is 6 centimeters. LM is 5 centimeters. Let's tell which triangle is congruent to which triangle. Let's start off with one of them. Pick a way to rotate, it doesn't matter. How do you want to, what do you want to call this one?
HJM.
HJI. HJI. I know that is congruent to triangle. HJ is going across the 7 centimeters. So you either say LN or NL, it doesn't matter, right? LN. Actually, it does matter.
You have to choose which side.
Yes,
you go
because
HJ.
so 7 to 5. So 7 to 5, it'd have to be NLM. I had it backwards. And now you can check and make sure NL, is that the same thing as HJ? Yes. LM 5, is that the same thing as JI? 5, yes. So now based on that information, since these triangles are congruent, I know all the pieces are congruent. So angle IHJ. This angle right here. Which angle is that congruent to over here?
Angle N.
Sure.
What do you?
Sure, I use 3 letters to say it.
Oh,
IHJ. This would be just angle H, yes, would be congruent to angle MNL. IHJ, MNL. Yeah, I like to use my stuff right here. Angle MNL. So actually angle N and angle H.
But in that situation, it wouldn't matter if you put M or L first, right? It's just like L and N.
Correct. You could put LMN or MNL. Yes, as long as N's in the middle. Okay, so we have other triangle congruencies that we did not get to today, but we will pick up on those next time. So we are going to stop there. You do have the bookwork homework's due tonight. Yes, I didn't have time for ask a question. Were there any issues on that at all?
I didn't find it.
Okay. So yeah, bookwork homework's due tonight, and then your next homework assignment, the one we passed out last time, will be due Tuesday, and then you won't have anything due on Thursday. Brittany, Samantha, and Deidre, do y'all have a compass and a protractor and a ruler?
I have here today. I have a ruler and a protractor. I'm just trying to find a compass.
Okay, do you need help finding one, or have you just not gotten around to doing it? It's fine. I'm trying to help them.
I found one. I didn't have a chance to like order it yet.
Okay, perfect. What about you, Brittany?
I haven't ordered it, should be at my house right now, actually.
Okay, perfect. How about you, Deidre?
So I have an old school compass, which as you said, doesn't work very well. is there one you can find in store or do you have to order online?
I actually don't know the answer to that, but I can look it up and let you know. I'll go look it up and I'll email you if I find one in a store that you can
Is
do
there
that.
still teaching stores that are open or no?
I have not been to one since before COVID, so I actually have no idea. I'm wondering if like Walmart, does Walmart just have the old Compass?
There's one on Amazon, like the one you're holding right now, that's like $5 and some odd cents.
Okay.
Yeah, I was just curious if I could just go to the store and get it, but
Well, let me look it up on Walmart. I feel like Walmart should have it, or Staples, maybe. Let me look at here. I have the Walmart app. Let me pull it up. Let's see. I know that this is weird, you being online and not sitting in the store, sitting in the classroom. So I just want to make sure that like, y'all don't have to talk or whatever, but I just want to make sure you feel included and can ask all the questions and everything. It looks like all the Compasses are all the ones that I was saying aren't the great ones. They still work. I just feel like they're harder to work with.
yeah, it doesn't stay, like it moves.
I hate those. So yeah, maybe ordering off of Amazon. Like, and honestly, on your homework and classwork, it shouldn't be a big deal. It's really the test is where it comes in. So I think ordering it should, is it come in pretty soon, I'm assuming? Let's look on Amazon. Found this. Oh, that's nice. Oh, this is called a safety compass. I bet that this is for like kiddos, so they're not poking each other in class. But I do feel like it's easier to work with. Well, it's taking a while to load. I can look this up. Oh, here we go. I can send you a link if you want a link for it. Oh no, that's way too expensive. Oh, I bet it's this one right here. Yeah, $5.04. It's this one, orange. It's that one right there.
Okay.
So yeah, I would probably do that. I think that's your best bet. But if you just look at like safe and then the letter T compass, that's how it came up.
Can you tell me how we did that again? I just want to write the instructions down.
Yes. Okay, so do you need anything else? Are you good?
I think I'm good.
Okay, we'll see you on Tuesday. I was gonna let you just. And here's the instructions for it, but for this one, you just pick any 2 points on the line.
Okay.
For the one we did first, you had to use the endpoints to make it the midpoint, but just for perpendicular bisector, it's the same thing as the midpoint, just pick any 2 points, so they can be really close together.